In this lab, we will be exploring the physics of a pulley on an inclined plane. We will demonstrate two trials with two different weights to find the coefficient of kinetic friction between glider and the track when air is not blowing. We will also determine the force of tension in the rope between the glider and the track. First, we have to take a video with each of the masses provided. Make sure we use a camera that records videos with the minimum speed of 30 frames per second to ensure quality and accurate analysis. Secondly, it is important to find and understand the forces that are acting on the glide and the masses during the trial. Therefore, drawing a free body diagram is the essential step in determining the known and unknown variables. Label the forces acting on the glide, which is mass 1, and the mass on the right, which is mass 2. For mass 2, we can see that only the vertical forces are acting on it, which includes F2 going down and Ft going the opposite direction. On the other hand, with mass 1, we examine the forces parallel and perpendicular to the surface of the incline. On the parallel, which is the x-axis, we have Ft acting on one side, while Fg1 sine theta and Ff acts on the opposite side. On the perpendicular component, which is the y-axis, we have Fg1 cosine theta acting towards the surface, and while Fn acts on the opposite direction. Don't forget to determine the Fg1 as it is used to find the perpendicular components. As we are given the values of the masses and measure the angle theta, we are able to determine most of the variables. The only unknowns are force of tension, force of friction, the coefficient of kinetic friction, and the acceleration of the whole system. Finding acceleration is very important, as you can use it to solve for force of friction, the coefficient of kinetic friction, the force of tension, which you will see in the later calculations. To find acceleration, we will analyze the video with Windows Live Movie Maker. For the camera we used, its speed is approximately 30 frames per second. We also found out that every 0.03 second holds one still frame. To begin with, we will create a chart as shown. Choose a starting point of the video during the glide is in action. That point will be the first frame. Step 1. Examine the initial position of the glide and record it in the chart. Step 2. Click the next frame button to go to the second frame and record the position. Step 3. Move to the 29th frame and record the position. Step 4. Move to the 30th frame and record the position. Repeat the 4 steps with the video of the second trial. After completing the 2 trials, you will end up having these results. This is the most exciting part of this lab. We finally have enough information to calculate the coefficient of kinetic friction. To find the coefficient of kinetic friction, we will start by applying Newton's second law, F net equals to ma. From the free body diagram, we know that F net is equals to Fg2 minus Fg1 sine theta minus Ff. We also found the acceleration from the video. Therefore, we can isolate the coefficient of kinetic friction to one side of the equation and solve for it. With the acceleration we found earlier, you can use it to calculate the tension. Refer to the free body diagram. Pick one of the masses to do the calculation from. In this case, we can use mass 2. Well, we're finally finished. Thanks for watching.